Well, hello, everybody, and welcome. This is the CESMII Community Technology Preview, and we want to thank everybody for being here. We're really excited about the information that we have to share with you. Just quickly, want to let you know that we are going to be on video here right now for a minute for introductions. That we will switch the video off to present our content, which I'll explain all that content in just a minute. And then we will come back on at the end for a live Q&A session with everybody. So explain the logistics and the functions of the meeting platform here in just a minute, but first I want to take a minute to do introductions. My name is Mike Yost. I am responsible for outreach here at CESMII, and I'll be your moderator, facilitator for today's conversation.
And I'm Haresh Malkani. I'm the Chief Technology Officer for CESMII. Glad to be here.
And I'm Jonathan Wise. I'm the VP of Technology for CESMII, and really excited about what we're going to be sharing today.
And I'm Prakashan Korambit. I'm a computational scientist at UCLA. I work with all the modeling projects and workflows with CESMII.
My name is John Lee. I work as an analyst and on the back-end side for CESMII.
Okay, and with that, we're going to switch and go back to presenting content, so you don't have to look at us the entire time. Haresh, you can share the screen again. Explain to you a little bit about how the afternoon is going to work and what content we're going to cover. Okay, so from an agenda perspective, we're going to break this up primarily into three sections. We're going to take the opening 30 minutes or so, and Haresh and I are going to talk through basically an opening of what we're all about, what CESMII is here for, the vision of the technology platform, future positioning, and things like that. We will then get to the heart of the matter, what we're all here to see, which is the demonstration of the Smart Manufacturing Platform and several applications, partner applications and such. And then we will come back, as I mentioned a minute ago, by video, and we will do a live Q&A session for the remainder of the time. And we'll flex that time as much as needed based on how quickly we get through the content. So as we get started, just a few things to note. First of all, you probably have already figured out that your microphones are muted. Your microphones will remain muted throughout the session. We are expecting upwards of 200 people today, and so we need to make sure that everybody can hear. So we would ask you instead to use the chat button to submit questions during the event. And if you look at the bottom right of the screen, circled in red, there should be a toolbar with your Zoom meeting that allows you to chat. So please text any questions that you have for any of the panelists in that window, and we will respond to those. You'll also notice that anytime we have the video going, you will see thumbnails of the presenters. If you want to change the way those thumbnails look on your screen, simply click on them, and then Zoom will give you options on minimizing them or expanding them to your personal preference. And then lastly, I just want everybody to know that we currently are recording this event, and we will post the event online early next week. Additionally, any questions that we don't get answered in the live Q&A session today, we will respond by email, and we will pull together in a document for everybody to review. So the goal of today is to get me out of the way and get Haresh and Jonathan talking as quickly as we can. I just wanted to take literally 2 minutes or less to just remind everybody of what we're here for and what this milestone event means for us here, showing the technology platform. We talk about a focus as an institute of democratizing smart manufacturing, and we talk about it in 3 specific pillars. And if you saw the animation, it started with technology, transitioned to knowledge, and ultimately ended up with innovation. Haresh and I have a pretty good back and forth about whether the technology is more important than the knowledge sharing or not. Since I am responsible for the knowledge side, not the technology side, I tend to champion that position. But I've been in this industry in manufacturing for 30 years and in the automation, industrial software side of things for 20 years. And I can tell you that if we don't address some of the technology barriers in the way, we're not going to have access to the data that we need to actually build and drive the culture that leads to innovation. So I will give Haresh his credit that what he's working on, him and his team are working on here, and actually the whole community is working on from a technology perspective, really unlocks the opportunity for us to work together as a community, to share knowledge, and ultimately to lead toward unlocking innovation. And so just lastly, from my perspective, really want to challenge everybody at this point to just consider what is possible, right? The name of this event we're here discussing today has been titled the Community Technology Preview. And that means that there's value for all of us being part of this community, in addition to value of the technology itself, which will be the main focus of today's conversations. So just think for a minute about the value of what we're after here as a community, right? Being able to accelerate the technological and the cultural transformation for all aspects of the smart manufacturing ecosystem. We have the opportunity to drive acceleration of the adoption of smart manufacturing solutions, not for the purpose of selling more software or selling more solutions, but because of the business value that these solutions can unlock at a plant level, at a business level, and at a national level as well. So being able to rapidly enable the practical use of terms that we hear all the time: industrial Internet of Things, artificial intelligence, machine learning, being able to deploy those at scale and get them working for our community is significant. Being able to have an IT-sanctioned, secure, scalable platform for operations technologies, or OT, or plant level automation data, that allows openness and application interoperability, and our ability to then use those standard ways of connecting and communicating and working together to train an entire implementation ecosystem. So systems integrators that focus on the OT side and the IT side, working together with common understanding of how to connect and collect and drive business process value across the entire enterprise. So from a community's perspective, there's significant value for being part of what we're doing here. I want you to keep that in mind here as we go through and talk about the value of the technology, which Haresh and Jonathan will go into deeply. But just going into that, think about the possibilities we have in front of us to dramatically simplify all aspects related to ingesting and contextualizing OT data. Right? The ability to dramatically reduce the time to develop new applications that drive value in the plant and across an enterprise. The opportunity to reduce the time to value for implementing those solutions, the costs, the risks, the complexity, et cetera. And core to who we are and what we're doing, the ability to drive those solutions into manufacturing operations of all sizes. This is not just a game for large manufacturers or large plants, but rather the ability that we are out to drive is driving value for manufacturers of all sizes. So with that, I just wanted to set the stage and turn the floor over here now, and Haresh will take over and talk through what you're going to see and hear in the remaining time that we have here together in our Smart Manufacturing Platform technology preview. Haresh?
Thank you, Mike. So there's a lot of information that we'd like to share today with you in the next 75 minutes or so. And what you will see and hear today are the following things. So first of all, we will talk about what is CESMII's Smart Manufacturing Platform. And for those of you who are in the business of leveraging and using platforms, you may ask, what is unique about what we do at CESMII? That's the first thing we'll talk about. The second thing we'll talk about is the CTP itself, the Community Technology Preview. What does it mean? Where does it fit into our plans? And why we think it's a big deal now for our members. We've had a tremendous amount of effort that's put in by some of our partners who really stepped up and made this possible today. So, who are those partners and how they've helped us. Then we'll move into the actual demonstration of this SM platform, and Jonathan, our VP of Technology, will take that over. And then just a sort of a preview of what's coming up next. As we're done with the CTP event today, there's going to be a ton of activities that will take place soon after, and we'd like to share that. And then also how our members will benefit from this CTP release. And then we'll open up into Q&A. So for those of you who are familiar with the roadmap for CESMII, you will notice that there are 4 major strategic items on that roadmap. And if you look at the bottom right of that roadmap, the SM platform infrastructure is one of those. And that's a very critical strategic goal for the Institute. And so what we are talking about today fits into that. And it leverages and it has natural connections to the other 4 pillars of the Institute's strategy. Now, let's for a moment go back to what a typical manufacturer may want to do, right? So when you talk about Industry 4.0, smart manufacturing, big data analytics, what is exactly that they really want to do? And if you begin at the bottom of this picture where it says sensing, you're essentially looking at your manufacturing processes, you're sensing what is going on, and then over to the left, you now need to take that data and then contextualize it, make some sense out of it, organize it in a fashion where it becomes useful for your visualization and analytics applications to work on that data. Once you've done that, then you move on to understanding what's going on, why it is happening, when it might occur next. And you're moving from a reactive role to a more proactive role. And then as you do the predictive modeling, you can bring back all that knowledge and intelligence back into your control systems so that you can either avoid that situation or you can prepare and be proactive to be better the next time. Now, one of the key things that our manufacturers also want to be able to do is that they want a seamless manner in which the movement of information takes place between each of these blocks and around the loop. And that's a critical element that is served by technologies that make up the smart manufacturing platform. So when you look at if you think of the iPhone or the Android phone as a platform where application developers and consumers come together, this is somewhat like that. You have a platform for manufacturing and manufacturers. And around this platform are these functions that are listed here, which were part of the last slide as well. So you talk about sensors, you talk about connectivity, contextualization of information, applications that allow you to do analytics, modeling that could be data-driven or physics-based. You need to be able to orchestrate information between application and across the layers through these operational technology workflows, and then eventually get down to connecting back into your plant control systems so that you can control your processes better and have an impact on things like precision, productivity, and performance. So what is unique about what we are doing? One of the key elements that we just mentioned was this frictionless movement and secure movement of data. And the important thing is not just data, but data in context. So if you hear some of the manufacturers who are trying to go down this journey in Industry 4.0, they'll tell you that a tremendous amount of time is spent in cleaning up, massaging the data, organizing the data, before they can even get to the point of doing the analytics. And we want to take that away. We want to reduce that pain to a large degree. And so movement of data in context is important. We are going to introduce a concept about SM profiles, smart manufacturing profiles. And these are essentially a manifestation of common data models that are developed by subject matter experts for CESMII. And they essentially embody a tremendous number of characteristics that are used to represent a process or a device or an asset. and a little bit more on that in a few slides. The third item is around interoperability. This is a very, very critical aspect of it. And we want to be different in this platform by providing a way for operational technology, OT applications, as well as IT applications to interoperate, whether they are from multiple sources, multiple vendors, academia, industry, whatever it may be. And we want an ecosystem under which they can all play together and connect and interoperate. Next one is the ability for multiple companies to work on the same platform. You'll see that there's a lockdown phenomenon out there when you talk about some of these IoT platforms where you have to pick a vendor and then you essentially go with that vendor for all your implementations. But what that does is it locks the data into that system and makes it not as freely available for other applications or other vendors to interface. The next point is around collaborative development. Because we are a public-private entity and an institute, we have the opportunity to develop these technologies in a collaborative fashion. And that's an important aspect of what we're doing in the institute. And then last but not least, we are embracing a number of standards that are already out there. So we're not going to recreate any standards. We may come up with some de facto standards that allow us to work on our frictionless movement of data, but we will embrace what's out there. And we might have some discussions around what are those standards and how we are leveraging them. So what are the core capabilities of the SM platform? Some of it you will see today in the demonstration. If you look at the bottom left here, the first block is around ingestion and connectivity. Connect to your data sources on the shop floor, on the manufacturing floor. Do the data collection, do the ingestion of that data. And then the next step is to contextualize that. So that capability must exist in this platform to be able to create the data models, to be able to organize the data in a fashion that is consumable by the applications. Next is the orchestration capability. Again, movement of information from these layers, from ingestion all the way to the applications or in between applications. That orchestration has to be done in the platform. And then on top of it is a CESMII marketplace where we will host a number of OT applications, as well as what we are calling the profile library. And you'll hear a little bit more about that. But this is where a lot of the data and the information is going to be consumed to provide value to our membership. All this will be combined with the ability to provision a platform instance for you. And we are leveraging a hyperscale cloud provider to be part of that. So essentially, these are the core capabilities that we are looking at within the platform that will be demonstrated to you today. Another view of this is the number of layers that represent the functions that I just talked about. So if you look at the bottom part here, at the very bottom is where you actually have the manufacturing process, you have the devices, you have the machines, and the next layer there is the edge layer, which essentially gives you the ability to connect into those data sources. And a number of standards may be used there. We don't want to recreate those. So we ingest that data using those standards and bring them on to the next layer, which is the SM platform. And that contains the capabilities for data management, data contextualization, data storage, and then application programming interfaces that allow applications in the marketplace to interface with the platform and the data that is being collected from the floor. So those are the main layers. And at the top are basically all the applications, whether they're commercial, off-the-shelf applications, artificial intelligence engines, workflow applications, homegrown applications, and a number of our members would be providing their expertise and their applications to be part of that marketplace as well. So that's really what we're calling a architecture with the three specific layers in it. On the right-hand side is the marketplace, which would then host the SM profiles, the member applications, the platform itself, and a profile designer, which essentially allows our members to create the smart manufacturing profiles. The key thing that we need to remember here is that we need to have the ability to interface and integrate vertically from data ingestion all the way to the application, as well as in between applications. And that's where the interoperable aspect comes in. So the ability for a commercial off-the-shelf OT application to actually talk to a workflow engine or to talk to a homegrown application, that is all enabled by the platform. So we mentioned briefly the concept around smart manufacturing profiles, and I'm just going to spend just a minute here. I mean, we are happy to share more details with you as needed. But a profile essentially captures the key attributes, whether it's a device or an asset or a flow path. And on the right-hand side, you'll see the hierarchy that we have in mind from device to machine to processes. And it could be a single process step, it could be multiple processing steps, all considered to be a single profile eventually, but they're all built up of smaller components. And these profiles, because they contain information that can be looked upon by different people with different lenses, because they come from different functions. So if you're a quality person, you may look at the data in one way. If you're a production engineer, you may look at the data in another way. And we need to incorporate all of these lenses into this structure. And so hence, it is important that the profiles are actually developed by our members and our technology partners collaboratively. These profiles will then, like I said before, will enable the components and the applications to interoperate within our ecosystem, within our platform structure. And we'll make all of these available in the SM marketplace, the smart manufacturing marketplace. And there are multiple ways in which the profiles can be used. The bottom picture here illustrates that on the left-hand side, you could simply access the profiles in your existing infrastructure and existing applications and have an API to it. Or on the right-hand side, you could leverage the CESMII platform and the CESMII applications along with the CESMII profiles to build your solutions. So we've talked about what the platform means and how it is unique from a CESMII standpoint. But what is actually a CTP? So there's a definition out there by a fairly well-known software provider. They call it a version of a software that is released to early users and software developers. In our mind, this is an early manifestation of our SM platform. And what we are going to show here are a set of core capabilities that are immediately usable by our members. It is not the final product. It is not the gold standard, but it is a step in that direction with enough capabilities that are immediately usable by our users, with the understanding that eventually it will evolve into a full-fledged, functionally rich platform. So an example might be that you might have a very basic car that gives you the steering wheel, the wheels, the engine, so on and so forth. But then you want to build towards a car that has automatic transmission and cruise control and all the comforts that you need, eventually with a goal that you would actually be performing on a racetrack. Right? So just think about that as a parallel to this. So why is this a big deal? First of all, this platform is going to be very simple to provision. So you come to us and say, we want to use it. It'll be fairly straightforward for us to put together something for you. It's going to be secure because we are using products and technologies that have that built in. It'll be very simple to connect to operational technology sources, your plant floor data sources through standards. There is a fairly sophisticated set of technologies that we are using around ingestion and contextualization for the platform. And then we are ensuring that the platform is extendable and has lived up to the expectation as far as interoperability is concerned. Now, this CTP version that's going to be out there is going to be available for our members on a free trial basis. And you can use it for roadmap projects, for application projects, and for non-production R&D testing and evaluation. And all of these will need to be vetted at this point in time because the CTP requires a little bit of a collaboration between our members who want to use it and the technologies that we're putting together. And I mentioned earlier on that we are actually making a tremendous amount of investment in the platform, but more importantly, there are several partners who've actually stepped up to help us realize this vision. And what you're seeing here are some of the names that have stepped up, including partners like ThinkIQ, Savagent, Emerson, MathWorks, ATOLOGY, Kepler, as well as OSI. And we are all working together with the CESMII teams and the membership to make this happen. So this is the overall functional picture of the platform as we are making that available for our members. For the CTP, if you look at this diagram, the layers that we had shown earlier on, the one piece that's missing in here is the data contextualization through profiles. You will see a very powerful contextualization tool, but we have to still build the profile concept to make it available in the platform. And that's going to take place in the next few months after we are done with this release. But importantly, here on the top left are the partners that have essentially stepped up to help us launch this. And then our goal is to have every manufacturing software vendor to become a citizen of this platform. So what you will see in the CTP demonstration today is the following. You will first see the provisioning of the platform. You will see the ability to ingest. The use case that we're using is for a compressor, data from a compressor into the data model. You'll see the ability to detect an anomaly and fire off a workflow based on the information that has been ingested. You will then see the ability to request an analysis by MATLAB, by a MATLAB program, and some other external systems. And the ability to then determine the impact of that anomaly on the downstream material flow. So we've picked a use case which will demonstrate some of these core capabilities of the platform. And with that, I will hand over control to Jonathan Weiss.
So just as I tee up the demo here, there's a number of teams that worked really hard on this, and software demos are always nerve-wracking. But we're going to go through it. This is real software, and the mistakes you see are probably mine. This is a preview, so just sort of to manage expectations. There's a lot that we got working. There's a lot we have left to do, but we wanted to get this preview out in sort of the spirit of agile development so we could start gathering feedback and kind of leverage your input to help us steer this as we develop it. We're going to start today in the CESMII member experience. This is a portal where you'll request and fire up your instance of the platform. If this is your first time through, you'll need to create a username and password. But if you've been here before and you have existing systems, you'll see them in the list like I do. You can see that these are being powered by ThinkIQ. They're a key member of the CESMII Smart Manufacturing Platform, but you're going to see some other members as we move through the demo. You might have also noticed Acme at the top. We'll tell you more about them in a minute. Since this isn't my first time through, you can see that I have a couple systems already, which we're going to use later in the demo. But let's pretend this is my first time here and go through the process of creating a brand new instance of the platform from scratch. So I'm going to request new. I'm going to call it the CTP demo, my demo platform. And I'm going to agree to the terms of use. When I hit submit system request here, a bunch of actions are going to take off in the background, provisioning all the services that I need for my particular instance. That process takes about 4 to 5 minutes. So we'll skip ahead to another one of my systems that's already up and running and do the next part of the setup. I'm going to use this clean demo. And the first thing I need to do as a user of that demo is request an account. So I'm going to do that here. Put in my name, put in a username and a password. I'm going to hit register. Now, what's normally going to happen is that there's going to be a confirmation and approval process. For today, I'm going to move past that, and I'm going to log in with an already approved account, just for the sake of the demo. So that's here. You can see that I'm in the clean version of the platform. It's up and running, but it has no data. There's no model. There's no connections established to our manufacturing system. So that's what we're going to do next. And for that part, we'll need someone within the on-premise system to help. There's an important reason for that. The connections we're going to make are outbound only. That means we're not reaching down from a remote system into the firewall. Instead, with the appropriate approvals from the customer site, we're going to reach out to a trusted service and establish an outbound connection. There's two-way signing certificates, one on each end, to make sure that channel is secure. I've asked Johnny Ortega from ThinkIQ to help me out. Johnny is on site on an IT-approved machine within the customer network, and he has secure access to the Pi server and to an HTTPS endpoint for this newly provisioned system. So we're going to take a look at his computer next.
Okay, let me share. All right, so what you're seeing right now is the on-premise system. It has OSI Historian on it, and you can see that I am logged into the clean system over HTTPS in my browser here. What we'll need to do is now create the connector in the CESMII platform, and then download and install that connector on-premise here to get the outbound communication going. So let's start that process. I'm going to go to Configuration Connectors. I'm going to select adding a connector. I'm going to name this Johnny Pi here. You can see here I have a connector type. It's currently OSI Historian. You can see there are other options here as well, and in the future there'll be more. But for today, we're going to stick with OSI Historian because it's very prevalent. So let's get this thing wired up. Submit that. And you can see here that it's added to the list. And I'm going to select it here to now download it on-premise, the connector installer. So let's do that now. So you can see here in the bar that it's been downloaded to my download directory. And it also here gives a message that shows an activation code. So let me copy that activation code, which is good for here for 4 hours. And after 4 hours, it'll become invalid. So you have that window to install this connector. Close that. All right, and you can see here in the connector list that you have the activation code as well as when it expires in case you forgot to copy it or you want to go back and get the activation code. So here I have the downloads directory in this console window. You can see that it's here and downloaded. So let's run the installer. Okay, so now it's installing the connector here on premise, and it brings up this configurator window, which asks for the activation code and also gives a piece of information that you can configure. Basically, this is the data root folder, which the connector uses to buffer data as it goes out to the CESMII platform. But we're going to just use the default today. So let's copy and paste, let's paste the activation code here and start the process. All right, it will give some status here. As you see the different tasks happening. I'm going to highlight the one particular part of this is the generation of the connector certificate and the exchanging of these certificates with the platform server. So what's happening is, you can see the first step, we created that certificate, and now the connector is passing it over to the platform server, which is used to validate the identity of the connector. And then likewise, the server has its own public certificate, which it is being passed over to the connector, so the connector can validate the identity of the server as well, which in the end means both ends of the data connections are secured. Next, we have let me close this here. There is one piece that we have to do manually currently, which will be automated in the future, and that is that the installer creates services for monitoring and sending the data, so we're going to have to start them up ourselves in this go around. Let me bring up the services window. I'll refresh. And there are 3 services that are being installed. The connector, gateway, and the monitor. All right, so I've started all 3 of them. And we're done. That's all it takes to really set up a connector to communicate with the CESMII platform. So back over to you, Jonathan.
Thanks, Johnny. So that was pretty simple. We're connected to the on-prem data source, and data has begun to flow into the platform. This will get even easier as the platform evolves, but for now, we're going to have to take some actions on the portal side. So I'm going to go over to building a model of the operation. For today's preview, I'm going to have to do some of these steps myself. But this model that I'm building, the structure of the data, the relationships between points organized as objects, and the relationships between those objects, we believe this is key to creating meaningful information value. And that's why CESMII and our members are investing in smart manufacturing profiles. We can't show those profiles as part of today's preview because that portion of the work depends in large part on having the key building blocks of the platform in place. But this is our jumping off point, the foundation from which we want to establish the profiles and use them throughout the platform. The connector, the model, and even the applications that use the platform will all be enriched and simplified through the profiles. So as I walk through some of these manual steps, imagine with me how much simpler this could be if the model already existed. First, we're going to take a look at some of the tags that'll be important to our data model as we build it out. For the sake of our demo, I'm going to start historizing some of them now. So the system already knows about them by virtue of connecting the OSI Pi system from on-prem. What it doesn't know at this point is how I want to use them. So I'm going to start defining those relationships first by location. So this is my clean system here. Below that system, I'm going to create plant 1, and it is a plant. And I'm going to create a mixing area within the plant. This is the first kind of relationships, and you might be familiar with these as sort of a physical hierarchy. But within that hierarchy, I want to create some objects that are going to store some of this data. And for the demo, we're going to be looking at a compressor, and a compressor is a piece of equipment that I have in lots of different places. So rather than just creating the compressor, I'm going to create a type called compressor. This is sort of an object-oriented approach where I define something first in the abstract. This is a generalized definition of a compressor. that is reusable. It itself inherits from a generalized description of equipment, and that is also reusable. And what this means is that anything that inherits from equipment brings all its attributes, and anything that I create based on a compressor will inherit those attributes. So I'm going to define some of those attributes that are common now. There will be cases where I have a specific compressor that has unique properties. That's supported, but thinking in the abstract, this is the right place to start. So I'm going to have temperature in degrees Celsius, and I'm going to have pressure in pounds per square inch. So if this is the abstract definition, to actually begin using data, I need to create an instance or a specific definition. And I'm going to do that here in equipment. I'll give it a refresh to make sure everything flowed through. And I'm going to create the mixing compressor. And it is of type compressor, so it inherits everything that's true about the compressor type, and it belongs to the mixing area. From there, I can see the attributes that were defined as part of the type definition, defined in the abstract. But I want to bind them to actual data. This is a real instance of a compressor. It's in the mixing area, and it needs real data. So I'm going to do that here. Oh, I'm going to do that in equipment with attributes. There we go. This is my pressure variable, and it's coming from pi. And these are the data points I primed earlier. And then temperature as well. Okay. So just as a quick recap, I created a base class or a type definition. I created a specific instance in a specific area in my plant, and I bound it to specific data. I can now trend that data and see that it's already begun flowing from the Pi system. I can keep going with this, continuing to model my operation, but that's probably not worthwhile for the sake of this demo. So I'm now going to switch to a system where more of that modeling has been done. This is our Acme customer. And Acme is our kind of imaginary large contract manufacturing company. Their model includes their supply chain, where materials feed their different plants, where the materials processed, mixed and bottled, and then sent to warehousing, regional facilities, and finally arriving at third-party logistics suppliers. I can see that their model is quite mature. If I go here to the supply chain overview, I can see different objects and their relationships, and I can drill in even deeper to the process overview for the mixing area. So this is more detail on that. And finally, I can see the actual relationships between objects in the process layer. Here we've got a blue nitrogen air separator object. This is an object that's bound to data from the OSI Pi system on-prem, and it's in relationship with other objects, each bound to their own data source. This particular object is providing nitrogen into these batch tanks. Essentially, it's a blanket air cover that protects the color and flavor of the beverage. In other words, there's a relationship between these objects. Later in the demo, you'll see why having that relationship declared in a programmatically accessible way is so important. Below that, we've got a color and flavor batch tank. What this is doing typically is mixing together color, sugar, and flavor. And if I click on that, I can see the details of the material flow going into that tank. So the system here knows how full the tank is, how the material is flowing, and where the material is flowing from. Understanding these relationships can be really important when something goes wrong. And that's a situation we're going to explore today. So let's look at the nitrogen air separator. We'll trend some of that data. And you can see that there's a bit of noise, but it's kind of clustered around a mean value. And for today, this is okay. This is a kind of normal running system. This is what the data looks like. What we're going to do, though, is we're going to introduce a problem. We've got our data simulation hooked up to a data science tool where we can run scripts to exercise the platform against an anomaly in the data. We could use tools like this for analysis or exploration, but for today, we're going to use it to cause a problem. And I'm going to do that right here. Give that a second to run. And then return to that trend. And see what happened. If you happen to be watching the data live, it'd be pretty obvious that we transitioned from our normal state to something very clearly anomalous. This big spike indicates something unusual has happened with the nitrogen pressure. But the reality is there probably isn't someone watching all data all the time. In fact, our data science tool actually introduced this problem a little in the past, so it's more obvious for the demo, but probably less obvious to a casual observer. Unless you're watching and know how to interpret the data, this could be a problem that impacts your product quality. And this is where the power of ThinkIQ comes in. ThinkIQ is a key smart manufacturing platform contributor. They developed a lot of what you've seen so far today and some pretty great tools to react to it. But the Institute and the platform are more than just any one member. This is about working together with the best of breed to create more value than any of us could arrive at on our own. So while we're starting here in ThinkIQ, we're going to need to call in a little help. And it's all going to happen automatically because of the integration that's been built for our customer, Acme. Because nitrogen pressure is so important to Acme, we've written a little script that monitors the value looking for problems. This script is running directly against the data right within the platform. It's interacting with the objects, their members, and the attributes as the data is flowing, as those values are changing. Every time the pressure changes on the compressor, this particular script is looking at the standard deviation to see if we're outside a safe range. For the sake of this demo, we've said that standard deviation is 5. And what happens here is once the script sees that we're outside of that standard, it knows the process needs some help. So we gather up the anomalous data and we send it off to Savigent. Savigent's another key smart manufacturing platform member, and they bring a best-in-class operational workflow system to the platform. For Acme, we built a workflow to help handle these kinds of anomalies, and it's been triggered by that script running in ThinkIQ. The workflow is going to start by letting an operator know what's going on, and then it's going to walk through the steps necessary to resolve. The first thing we'll do is review, and potentially we might have the operator collect some additional data. In this case, they're going to proceed. They agree something's wrong, and the workflow is actually going to take over doing almost everything. It's going to kick off another kind of workflow first. This is a scientific one. CESMII member MathWorks provided MATLAB and Simulink licenses as part of the Smart Manufacturing Platform. So we've worked together with UCLA to develop a classification algorithm to determine what kind of anomaly we're looking at here. This is orchestrated through Kepler, which wraps the MATLAB call and returns the results to the Savigent workflow engine. Yes, we've confirmed these readings, and we're going to need to proceed. The MATLAB classification has indicated that the data is showing that this is most likely caused by a blown seal. Maintenance is definitely going to be needed to go fix that part. And we're going to want to send the data to a laboratory information system to understand the impact of the material change. All of that's happening through the workflow and being orchestrated in these steps necessary to react to this condition. Finally, the workflow is going to summarize all of the data and decisions that have been made and present to the user with a recommendation on what to do next. Now, all of that happened pretty quickly, and it might not be obvious what's going on behind the scenes. So I've asked Mark from Savagent to walk me through what happened as this workflow ran in the background.
Thanks, Jonathan. Let's start with a quick primer, just to level set everyone on how Savagent defines workflow. Workflow is basically a work automation system, which includes mobilizing data from data producers, sensors, machines, systems, humans, etc., interacting with those data consumers, driving decisioning, and ultimately taking action. Workflows in our world can be as simple as alerting a human via a text message that a set of conditions has occurred, to very complex where workflow dynamically and automatically changes recipes, reconfigures or calibrates the settings of a manufacturing line based on conditions, orchestrates all the actions necessary to get back to a state of making good product. While workflows are unique to each customer, there are common types of events, actions, triggers, functionality, templates, etc., which give us the ability to build solutions without starting from scratch. Actual implementations will vary by customer, of course, and the solutions that they're building, but each will involve leveraging smart manufacturing profiles and pre-built functionality components along with this common data model, which will really enable CESMII to drive ease of use, speed of adoption, and provide a high degree of asset reusability across the marketplace. Workflow implementations will be done by the customers themselves, their partners, or our smart manufacturing platform system integrators. So back to our demo. Let's take a look behind the scenes at the Savagent workflow environment. This is visually going to show us the workflow that was run and the execution and logic paths that were fired. We captured this via video to show you exactly what ran while Jonathan was clicking. What you see here started with a base template for an out-of-control action plan, which is basically a process template to drive human, system, and machine actions that get us back to our manufacturing happy path. In our example, the green ball in the upper left represents the start of the workflow. It's where the anomaly was triggered by ThinkIQ, requesting additional help from Savagent to confirm and diagnose, as well as orchestrate the remediation. As the data flows through the workflow, you can see the decisions being made, which determines the next action. You can follow that execution path as it highlights itself in red as it executes. The first decision point has to do with our operator. We ask the operator to confirm that set of conditions actually did happen, and subsequently request the operator to confirm that the information and the remediation is indeed needed. Note, in this case, and for this demo, we're prompting that operator for manual input here to show that interaction. As a customer's comfort level, maturity, and acceptance grows, the platform is capable of driving this remediation without human involvement, but not all organizations are ready for that level of adoption. As we determined more action was needed, workflow send the data payload to MATLAB for analysis. Our MATLAB classifier pinpointed and returned the type of the problem, identifying the anomaly as a blown seal. Given this from MATLAB, we knew we needed to take two actions. Workflow interacted with the maintenance system, logging a high priority ticket to dispatch the maintenance engineer to repair that blown seal. It also sent the data payload to the LIMS system to see if there was possible contamination of the produced products. So with a positive response for this contamination coming back from LIMS, we need to now update the ThinkIQ system with our findings and assess that impact. This is important because in this case, we need to do more than just fix the problem. We may have to pull some product out of the tanks or keep it from shipping to a customer. Fortunately, the smart manufacturing platform knows more than just equipment hierarchy style relationships. It also knows material flow relationships. So that's where we're going to head next. Let's determine the extent of the contamination and what to do with that possibly contaminated product. Jonathan, back to you.
Thanks, Mark. Well, let's follow that guidance and figure out what to do with the possibly contaminated product. So I'm going to click continue on the workflow. And I end up back in the material flow application in ThinkIQ. The information that came out of that workflow suggests that some kind of obstruction made its way through our damaged seal it's likely that some lubrication oil has made it into the product. ThinkIQ's material flow application uses the relationships defined in the platform to track material movement and show us exactly what the impact of that event is. We can see that it's pinpointing the specific tanks where the contaminated material has ended up as it flowed through the process. This can be instantly identified by ThinkIQ specifically because the relationships between the objects have been programmatically defined. So this was a bad day for Acme, but it could have been a lot worse. If they hadn't caught the anomaly, they might have ended up shipping bad product. If they caught the problem during manual lab tests, they might not have been able to pinpoint the source and could have ended up with a lot more waste than was necessary. Because of the Smart Manufacturing Platform and the power of the contributing CESMII members, Acme now knows what to fix and exactly what product to pull. From an operations perspective, this is useful information that was delivered from raw data because it had been put into context. Now, as a plant manager, you might not be responding to individual maintenance issues, but perhaps you'd like to see an aggregate view or report of where common issues were. Another contributor to the Smart Manufacturing Platform and a strategic partner for CESMII is Microsoft, which has provided some of the key operating system components of this platform through Azure. Microsoft also has some great tools for exploring data in context as well. So here's some of the data from today's event, and we're going to look at it in Power BI. If you prefer another tool like Tableau, that's possible too. Since this report is based on the Smart Manufacturing Platform object model, it maintains the link to the detail, so I can drill in and learn more about each of the incidents. Today, we walk through a single use case covering most of the steps, going from no platform at all to a working connected platform with data flowing, context developed and stored, and CESMII member applications and capabilities brought to bear, analyzing and responding to that data. This is just the beginning, and as the platform becomes available, we're looking forward to exploring new ways to leverage and integrate with it. So what we walked through was sort of the core portions of the platform, leveraging technology from some of the members. We weren't able to do the full scope of what we're after here. And there's at least two other participating members that we want to be able to kind of integrate with now that we've got a beachhead established. The first is Emerson's Plant Web Advisor. Plant Web Advisor uses a template-based approach to create information value from raw data regardless of sort of the uniqueness of a customer implementation. So the kind of front end helps the customer make decisions about maintenance, about their process, about energy consumption. And the templates provide a common data model that, once bound to the historian, allows all of their customers to have kind of the same experience. That template-based approach, the common data model that is really kind of the heart of their architecture, is directly analogous to what we want to do with the profiles. So we couldn't start that project with the platform because we didn't have the platform yet, but that's sort of the goal, is to explore taking the learnings from those templates, figuring out how to express them in an open standard like a profile, automate the binding of the data, and allow Emerson to sort of reduce the amount of infrastructure they need to deploy to get to a solution. Another participating member that we're really excited to begin integrating with is ATOLOGY. And ATOLOGY has this innovative approach to creating manufacturing information value, kind of skipping the traditional information architecture that's usually roughly based on the Purdue model, where you pull data up through layers until you finally arrive at value. Using machine vision and artificial intelligence, they're able to skip those layers and go straight from a camera pointed at a situation in a manufacturing environment to information value without needing to pull it through the PLC, the historian, up through the levels, and arriving at the application. The really interesting thing
for me about this is it allows us to explore kind of an advanced idea for the profiles based on a programming concept called polymorphism, where if we have a implemented customer that's got a traditional architecture and we can pull certain value through that automatically through the profiles, then we can work with ATOLOGY to develop a profile that is effectively an interface definition that allows them to augment the runtime object on the fly with this new additional data, regardless of the path to how that data was arrived at. Both of these are kind of next steps, next explorations now that we've got a common set of functionality available on a platform against which we can start exploring the profile creation.
Okay, great. Thanks, Jonathan. So just a little sneak peek at our timeline. If you see this chart, we've got a couple of things going on here. At the bottom are the RFP-based projects and waves that we've set forth. And so if you look at the absolute bottom one, we have 10 of the projects that were selected in the RFP 1 for the Institute. They have been launched as we speak here. We've initiated the first wave of the RFP 2, which is also the bottom part of the slide. And then soon, in the next couple of months, we'll have the other 2 waves of the RFP coming in. And some of these waves are tied to the activities that are taking place in the platform world. So on the top side of the slide, we are here today in August with the MVP CTP release. And then we are expecting to have a full release version 1.0 sometime in the first quarter next year. So that's what the timeline looks like, and we're obviously very excited to sort of move forward in that direction. So what happens now? We have the CTP version out for our members to be used, and this particular form of the platform can immediately be used by our roadmap project teams, the RFP1 projects that are already launched. It can be used for developing additional capabilities in the platform. So we have Wave 2 coming out soon, where we'll be asking for your ideas on extending the capabilities of the platform. We will have innovation project teams that will help develop the profiles and the apps for specific assets and processes. And then we have what are called application projects, where our manufacturing members will be able to use the platform to do some pre-production evaluation and validation and testing of their solutions using some of the core capabilities in here. And then, of course, as we move into the training activities, now we have a core set of capabilities around which we can develop some training for our members and implementers. So one example is if you look at the roadmap projects, we have one of our lead team members, Charlie Romberger, with us today on the phone, and I would ask him to maybe briefly provide his perspective on how he envisions the use of the platform on their project. So Charlie, if you can maybe spend a minute or so.
Yes, thanks, Suresh. We're, as you know, we've been here in a kickoff meeting the last 2 days, so we've had a lot of energy around our Castor project, which focuses on, of course, yield and productivity improvements. And as such, we've been anxiously awaiting the preview of the platform capabilities. So I guess from my perspective at this point, we have some initial challenges within this first 6-month period to begin focusing on data ingestion itself and begin textualization, so we can then begin driving some of the, let's say, applications improvements that we're interested in. So we will be very interested in gaining and learning some additional information as we move forward. So I'll be very interested in when we can begin to get access and what we have to do to get.
Oh, Charlie, I think we might have lost you there.
Where did we lose you? Where did I get lost?
just the last few seconds there. Is there anything, was that a closing point?
No, I basically I'm very much looking to get moving as quickly as possible and take advantage of the opportunities that we have being offered by the platform and, of course, the community that's being developed around the platform itself. So we're very interested to get started as quickly as possible.
Great. Thanks for that, Charlie.
Yeah, thank you, Charlie. We really appreciate that and appreciate the discussions here and the members' commitments. And so I just want to take a few minutes here and we'll flip over and continue with the theme that Charlie started as far as, our members excited about where we are and the vision and where we're headed. And so I have a few quotes here that I just want to review, have everybody have the opportunity to hear. And this is from Lindy, formerly Praxair. It says the company believes that more open standards and frictionless vendor interoperability are key enablers for the next step change in manufacturing productivity. This can only be done through strong multi-organizational collaboration partners like CESMII. Additionally, from Honeywell Aerospace, Greg Colvin says that CESMII's goal of providing a platform enabling efficient data management across manufacturing facilities, equipment, and business operation systems will accelerate U.S. manufacturers' adoption of Industry 4.0. Having access to CESMII's platform to help solve these pervasive data management challenges will provide competitive advantages to CESMII members and to U.S. industry. Ken Creasy from Johnson & Johnson Supply Chain said that the Smart Manufacturing Platform will unlock value by improving quality and reliability through visibility and transparency throughout the supply chain, enabling scalable, more cost-effective solutions, and by driving greater speed to market through formal solution selection and roadmap for execution. And one more here from Chris Damsgaard at General Mills, who says that just as CESMII is the home of smart manufacturing, we need this to be the platform of smart manufacturing. The cost and time to implement needs to be reduced drastically compared to the traditional approaches of $1 million in 12 months just to get started. So we bring these up just because we couldn't bring all of the members on. Obviously, we couldn't have all the members here in the room with us either. But just wanted to share that there's real excitement about where we are, where we're going. And those quotes that I just read were all from manufacturers. And I'm not going to read this next slide for everybody. You heard from several of these partners that were in the demo or have been referenced in the conversation so far. But just want to raise the point that solution providers as well are coming here and working in an environment collaboratively. And that's different, right? In most scenarios, these organizations don't have real drive to work together, and they see the value of knocking down these barriers from a data collection and data contextualization perspective, from an interoperability perspective. And so they're here connecting with each other, connecting with us, using this structure and this community to help drive things forward. So we've had a bunch of questions roll in by the chat. And so we have, I believe, roughly 20 minutes or so left, and we're going to transition now and turn the cameras on here, John, and we'll go to a Q&A session. As I mentioned earlier, if we don't get to any of your questions or don't get them all taken care of, then we will respond with follow-up emails, and we'll put together answers to all of these questions. If you think of additional questions after the event, you can use the email that's on the screen, info@cesmi.org, and we will respond to those questions as well. So if you want to, just shut down the screen sharing. As Just one question. Is Tom's line open? Okay. I just want to go back to one of the quotes. We've had this conversation many times, and so we knew that the topic of standards were going to be important. I just want to go back to what Larry Megan from Lindy said. He said that the company believes that, quote, open standards and frictionless vendor interoperability are key enablers for the next step change for manufacturing productivity. So it gets us into the realm of the conversations about standards. And so we reached out and we've asked Tom Burke, who's the Strategic Marketing Officer and the founder of the OPC Foundation, to join us here for our Q&A session. And Tom, are you with us?
Thank you, Mike. Yes, I'm here. Thank you. Thank you very much.
Well, yeah, just wondered if you could take a minute and ask if you agree with the statement about the value and the role of standards, and then comment on CESMII's approach as far as using profiles, whether you see that as a complement or a conflict with, say, OPC UA, which obviously you're very familiar with.
So this is a very exciting opportunity here. I'm very excited about what CESMII is doing, and the fact that the organization really truly is embracing, all the relevant standards in our industry, inclusive of OPC. As most people know of me, my whole persona in life is all about collaboration, and I think the importance of the organization, what CESMII is doing with collaborating with all the universities and with all the suppliers, and ultimately really working with the SIs and all the end users to really embrace smart manufacturing cannot be underestimated. I'm very excited about, I've had the opportunity to meet Mike and Jonathan, and I look forward to really meeting all of you. But the excitement of what's going on with the platform and the direction, this really will enable essentially a lot of the suppliers more easily to adopt and really get a really well entrenched into the Industry 4.0 for all the smart manufacturing. So I can do nothing except embrace the work that you guys are doing. It's just perfect. It's exactly what we need to do, and it's been exactly what we've needed to do for a long time. And I just hope that there's so many more companies that realize so quickly the power of what this platform really is and what it can do for you.
Well, with that, Jonathan or Haresh, do you have anything to add to or continue on to the points that Tom raised?
Well said, Tom. Thank you.
Okay.
Thank you.
Well, hang tight with us, Tom, if you can, and we'll see if we circle back to more questions about standards. Just a couple of points. There were a lot of questions about slides and the recordings and such, and the answer is yes. We'll get the slides out. We'll get the recordings out probably sometime middle of next week by the time we get everything pulled together, but we will get your questions answered and get information back out to everybody. There was a question, well, there were lots of questions here. One of the questions was, when you say that ATOLOGY skips the Purdue model, doesn't that have an impact on machine performance? Jonathan, do you want to take that question?
Yeah, so maybe I didn't communicate clearly. So ATOLOGY's kind of core technology is machine vision combined with AI. So I've yet to see machine performance degrade because it was observed by a camera. Their mechanism of skipping the Purdue model means they don't have to get data directly from the machine. They infer data through visual observation and their AI that's running remotely. So no, it doesn't impact the machine. It doesn't impact the existing information infrastructure that's there. In some cases, there might not be much information infrastructure there, so it creates one where there was none before. In other cases, there might be some, and that we really see that as a complement. And really our goal as we work with them is whatever information is flowing through traditional mechanisms, we want to make that easier to get access to. But then when information arrives through a non-traditional mechanism, can we create a union of those two things so that there's kind of consistency and context that's maintained throughout end users' information infrastructure, regardless of how it's implemented?
Excellent. We have a bunch of questions that have come in as far as access and availability of the platform. One question asks Haresh, do do companies need to be CESMII members with active roadmap projects to get access to the CTP at this point?
Well, the short answer is no. As long as you're members, you have access to the platform. But there are varied degrees through which you can get CESMII support in what you're trying to do. So as a member, you have access. But if you think of an application project, for example, then you have access to not only the CESMII platform, but also some of the CESMII resources to help you configure it and get set up. So that's as far as application projects are concerned and membership is concerned. If you're a roadmap team member, then obviously you have access to the platform as well. So I think in most cases, as long as you're a member of CESMII, you have access.
Okay, we had another question, actually two of them I'm going to put together into one spot. Jonathan, I think it's going to end up down at your end of the table. It says, cool to see that this is becoming real. Is this CTP still mainly an assembly of existing technologies from partners, or is there a bunch of unique code that makes up the platform, the SM profile builder, execution, et cetera, et cetera, et cetera? And then there was another question about vendor interchangeability and the views of the partners that are here at this point, but the opportunity and the ecosystem expanding beyond our current vendor base. So could you touch on those?
Yeah, that's a lot to unpack there. So I think the pointed answer to the first question is, yes, we're working with partners largely with their existing technology and kind of leveraging CESMII and some of our core ideas to influence their roadmap or work together with them on an implementation that can begin to explore some of these ideas and connect some of these threads. And that's really where we're at today. There is mature software available from members. We don't need to reinvent those wheels. As much as possible, we want to sort of leverage the best in class to create kind of this reference on which we can develop new things. The core thread that needs to go through is the SM profile, the Smart Manufacturing Profile, the concept that a model shouldn't need to be built by a human every time you do an information implementation. If we can kind of bottle that lightning once, then that should be reusable through kind of every layer of the stack. And CESMII's gonna, and our members are gonna have a big role in driving that, defining that through kind of gathering input from the membership and those that want to participate in finally solving this problem. So there was a second part of that question is there like exclusivity around this software as the only way to do this? I would say, and there's another question I see on the screen about what if a customer uses AWS, or what if a customer has an information project with another vendor? I would say pragmatically, we need to build a reference implementation, and we can't build 8 of them because we just don't have the resources to prove out these ideas, to build out the profile schema and kind of get people to rally around it. We need to explore in depth one way to do that. But these will be open specifications. They will eventually, hopefully, be open standards, and they'll be available for anybody to interpret, anybody to participate in. Whether they're helping guide the definition, or whether they're kind of constituent users that are using it to enrich their software or their own ideas that they want to explore. CESMII's making an attempt to float all boats, not to pick a few and turn them into champions, but to kind of raise the level for everybody to play on. Where we don't have to start every information project with kind of a 3-month integration effort.
Well, and that's part of the idea behind being a community as well, right? That the folks that we're working with have been here with us for some time, right? And been to the forefront and invested resources in a number of ways.
Yeah, and they get it, and they jumped in and said, this has to happen, so we're going to put our resources into it.
And it gives us something now to look at and start the dialogue about these types of questions. So,
and I'd say we'd invite anybody to do that.
Yeah, absolutely.
I'm not smart enough to solve this for everyone. We need the participation rate from everyone.
Right. You brought up in there in the first response about profiles, and there was a question here that says, is CESMII going to mandate that all profiles be made public, or will there be private profiles? There's a second part that I'm not sure is the same point. It says the actions taken in the GUI, will there be bulk edit entry mode for efficiency? I'm sure we'll get more efficient as we build up capabilities, but you want to talk about the profiles and sort of the model behind those.
Yeah, so I think we've heard loud and clear that there needs to be the concept of private profiles. Now, those private profiles aren't going to have a private schema. They're going to be based on the same standard. But it's been made very clear from the market that if I develop a profile, I may want to keep that just for me. And there's nothing about kind of the openness of the platform that would prevent that. I would say that's not my call. If you choose to distribute your profile because you think it benefits the greater good, awesome. I'm sure there will be a financial incentive to do that. But if for some reason there's IP or there's something unique to you or to your customer, nothing about an open specification requires you to distribute it. So then the second part was on bulk loading. I think I'd probably look to our member partners to talk about their particular UI. But in general, the idea is that if a machine or process can be matched, then the profile can automatically be bound. And we don't know how to solve that in every case. There may still be cases where we're going to have kind of humans clicking through. But as much as possible, I'd like to get ahead of bulk loading by doing automatic binding. And there are some examples of that in this industry, some of which I've worked on, where it's possible. There are definitely problems that we need to solve, but I think that's a good use of kind of CESMII resources and investigation.
Jonathan, there's another point that maybe we should bring up, which is that, if you're thinking of a process level profile, which is made up of profiles of different machines, and that's another way in which you can actually, quote unquote, bulk load, right? You don't have to recreate the entire profile for the process. You can actually make use of the building blocks and make it happen.
So we're looking about 5 minutes left here and about 6 weeks worth of questions, I think, flying in here. So a couple of threads that I'm seeing through here about cloud and edge and things like that. So maybe a quick point on those. Question is the cloud a requirement for the Smart Manufacturing Platform, or will there be a non-cloud version? And then there's a follow-on separate question that says, can you discuss plans for the edge connector?
Okay, and then Kubernetes has been asked about a couple times. So I'll say that today's implementation is cloud-based and leverages Kubernetes both for deployment and scale. In my mind, there are different interpreters of the profile. There are at least kind of 3 classes of interpreters, and the presentation that we gave you today showed a typical placement of them, where the edge interpreter ran within the premise, and then the platform level or the core interpreter that created the object model ran in the cloud, and then the applications ran in the cloud. There's nothing about the nature of interpretation that requires that stack. There is the fact that our current implementation was built that way, but that doesn't preclude exploring other kind of deployment scenarios in the future. The edge piece, in my mind, is sort of profile interpreter 0. It's the first one, and I don't think that we're going to prescribe exactly what that needs to be. What we want to guide is that an edge interpreter must have a base set of functionalities so that it can be leveraged to do data collection using the profile to tell it what to collect. And just like there may be other application interpreters and maybe other building blocks, sort of a platform that are interpreting on-prem or in the cloud, there may be multiple edge interpreters. The core thread, again, is will they support binding data to an object defined in a profile?
I'm going to pull us back a step because we have a bunch of questions around things I've never heard of, Kubernetes and Shekel and things like that. So way over my head, and that doesn't mean that we can't talk about it. But I know, Jonathan, you went high and you went low. You went wide, right? And so I know you went across a whole lot of boundaries as far as users and roles and things like that. So if somebody's a participant and they're looking at it and they're not someone who's deep in the technology and understands these integration pieces, could you talk about like what you've shown and how this will feed different users, right? From a technology perspective, a non-technology perspective, a business leadership perspective.
Yeah, so the first thing I'd say is, like, we're not gonna get to all of those in the remaining 5 minutes, so talk to us. Like, the idea here was just to kind of whet your appetites, show you what's possible with the pieces we have, and kind of cast forward to where we want to land with 1.0. So please engage with us beyond just this meeting, so that I can and we can understand kind of what your particular bent or focus is. I will say that in this demo, we very deliberately kind of hit on different roles or different personas that might be using it. There was some deep stuff there where we were looking at Python, and I apologize that there were some video quality issues in there, but not every user is going to want to write Python. But that doesn't mean that there's not value in what we've shown. It's just that that portion of the demo, we wanted to highlight some of the capabilities that a developer might be interested in. Building a workflow, like Mark mentioned, is customer specific. So you're not gonna hook up a connector and suddenly have a workflow that tells you what to do. You're probably going to work with an integrator or with Savagent to build a workflow that's kind of appropriate for your use case. So the gist of that is this demo deliberately hit on different parts that hopefully are interesting to different personas. There's a level of value that once we have profiles, everyone can get as kind of the new common ground. And then having the platform accelerates the exploration of the different areas of interest. Data science is another one that we lightly touched on. And all of those personas are invited to participate and invited to help us build this platform, help define profiles, and then help find ways to get value that is important to them from it.
Excellent. Well, we have about a minute left, and so I'm going to ask one more question of you, Haresh, because I think it would tie in with sort of the overall approach, and then you can take us out of here.
Sure.
Again, reminding everybody that questions not answered will be answered. We'll put together a document and make it available, and you could also send emails to info@cesmi.org. But the question is now escaping me. The question was, will more of the large automation providers like Siemens, Rockwell, Wonderware, et cetera, be coming to the party with this platform? Can you talk about our approach from engaging all of the ecosystem?
Yeah, so the answer is yes. We would love to have everybody on the table. Our CEO, John, has been on the circuit for months now, talking to many of these major players. And, they've, at least from what I have seen, have indicated a tremendous level of excitement in being able to work with us and join us. So our hope is that happens quickly, and then we can get, like Jonathan was saying, at the beginning of a conversation, we need to have conversations with our partners, with our members, so that what we build is usable by the larger community. So.
Any closing comments?
Yeah, I just want to, this was a tremendous effort on everybody's part. I just want to, vocalize the contribution. We've had a tremendous energy for the last several months building up to this CTP demonstration. So I just want to acknowledge the amount of effort that has been put in on the technical side by Jonathan in particular. He's led the effort to get us here, along with all the partners that actually have made the product real, right? The software demonstration you saw today was real. And this is actually real working products that were put up by companies like ThinkIQ and Savagent. And
Jonathan did very little. ThinkIQ and Savagent really worked hard to make this real.
and they've been with us along the way here. So again, I appreciate the contributions from them. We have contributions and partnerships that are on the horizon, from folks like Emerson and ATOLOGY coming in, and many others. I'm hoping that in the next few months we can start working with all of you as you bring your expertise back into the platform. And there's been a lot of back-end support that we've got from CESMII headquarters staff. There are two of them sitting in the back here. Mike has done an excellent job of pulling all this stuff together as an event. UCLA has provided us with infrastructure and facilities and to make this happen. So again, it takes a village, and it truly has. So I want to just thank everybody for bringing us up to you.
Yes, agreed. So with that, we will close today's session, let you get on with your day, and we'll get back to work and clean up the open items that we have coming out of this event. So thank you very much. Take care. Bye-bye.